Okay, guys, today we are going to discuss the attributes of quadratic functions. You'll notice the foldable that you have in front of you has a front and a back. So what you're going to do is you're going to flip it to the side where you can see all 6 boxes. Then you're going to take the 2 sides and fold them in until they line up with that middle line of the 6 boxes. And you're going to push them flat. Just like this. After we're done with the video, on your own time, you'll cut on those lines just to the fold, and you'll make 6 little windows so you can open up each box individually. But for now, all you need to do is fold it so you know where the folds are. When we're done, you're going to take this and glue it in your notebook. So let's open it up. We're going to start here in the top left box, and I will zoom in, wrong direction. Okay, woo, goodness, I think I zoomed in a little too much. There we go. Okay, we're going to start by defining what a quadratic function is. There are many different definitions that you could use for a quadratic function. We're going to pick one that kind of matches what we're trying to do. So the definition we're going to use is a quadratic function is a function of the form f of x equals ax squared plus bx plus c. And this function is symmetric about the vertex. And that's something we'll find later and we'll discuss it. This function is symmetric about the vertex. Okay, right beneath that, it gives you a function in that form. This very first term here is the term ax squared. A is the value in front of x squared. So in this case, a equals 2. The middle term is bx. Again, b is the value in front of x. In this case, b is 2. Then the last term is your c term, your constant. And that would be -4. This entire function is in standard form. This is standard form of a quadratic function. F of x equals ax squared plus bx plus c. And that's just the most basic form. Then we're going to move down to this box here. And it asks you for the definition of the y-intercept. Most of you can already determine what the y-intercept is. The y-intercept is the point where the function crosses the y-axis. And this is the same for linear functions, quadratic functions, exponential functions, absolute value functions, any of those. Wherever it crosses the y-axis, we call it the y-intercept. Now, using this information, I can tell you that if the equation is in standard form, the y-intercept is the constant at the end of the equation. And we represent the constant with the variable c, just like we did up here. C is that constant at the end. That's the y-intercept. And then it gives us an example and says, find the y-intercept. It's really super easy. The y-intercept is 3. Otherwise known as the ordered pair 0, 3. It's quite literally just the number at the end. Can't mess that one up. Yes, sir. It is that easy. when it's in standard form. Now, if it's in vertex form, the number at the end is not the y-intercept. But in standard form, it is. Okay? And that's only because it's in standard form. Vertex form we'll get to later. Okay. In the next box, it says how to graph a parabola. We're going to make this super easy for you. You're going to use a calculator. You're going to find a table of values. You do, however, need to solve for one thing first before you figure out what your table is going to be. You need to find the vertex. The way you find the vertex, and that's the point where it turns. If you look at these over here, see that point where the whole graph turns? That's the vertex. It's the lowest or the highest point, the maximum or the minimum. You need to find that first before you fill out your table. The way you're going to do that is by using the equation x equals negative b over 2a. B and A come from standard form, this that we did up here. A is the term in front of x squared, and B is the middle term in front of x, okay? So if I look at this equation here, what is my A value and what is my B value?
A is 2.
Oh, which one is it, 2 or 1? Okay, A is 1. What is B? Negative 2. Good catch. And just for fun, what is C? 3. Okay, I'm going to use B and A and plug it into this formula over here. X equals negative B over 2A. In this case, our B value is a negative 2, and our A value is 1. Well, if I simplify that, I have a negative 2, which is a positive 2, because negative times a negative is a positive. And on bottom, I have 2 times 1, which is 2. So I actually have 2 divided by 2, which is just 1. So the x value of the vertex is 1. Then you take this value and you go back to the original equation and plug it in to find your y value. So y equals 1 squared minus 2 times 1 plus 3. And we can simplify that. Well, 1 squared is 1. Negative 2 times 1 is negative 2. And 3 is still 3. So what I actually have is 1 minus 2 plus 3. Well, 1 minus 2 is a negative 1. And negative 1 plus 3 is a positive 2. So my vertex, which I'm going to denote with a V, is the ordered pair 1, 2. When you write your table of values to graph this equation, the vertex goes in the middle. So then right here next to it, I'm going to make a table. Just like we normally do XY values. In this table, we're going to put 5 ordered pairs because 5 points give us a really good picture of the parabola. In the very middle of my table, that's where the vertex goes. Then you're going to pick values that are less than the x value of the vertex and greater than the x value of the vertex. 2 easy values would be 0 and negative 1 for less than. And then if I keep going forward, I'll have 2 and 3. Then you can use your calculator. Take the equation, type it into y equals x squared minus 2x plus 3. Then I press second graph, and that'll bring up my table. I know my first value is going to start at negative 1, and I have 6 that goes next to negative 1. Then 0 will go next to 3. You can see that the vertex is accurate at 1, 2. Then the next value is at 2, 3, and 3, 6. And you can see that since the graph turns at the vertex, the values before and after the vertex are the same. This is going in ascending order in this direction, and this is going in ascending order in this direction. And that'll continue forever. Whatever value you have next up here will be the same value you have next down here. Okay? The y values will always be symmetric. Then, the easiest way to graph that is by plotting the points. It's not that hard. We're going to start by labeling the axes, y and x, and counting off. I am counting by ones, but I'm going to label by twos just to make it easier. So I know exactly what I'm graphing. And then I'm going to start with the first point at -1, +6. So I'm going to go to the left one, up 6, and put a point there. Then my next point is going to be at 0, 3. And you'll notice that that matches that C value you had over here for the Y-intercept. It crosses right at 3. And then my vertex is at the ordered pair 1, 2, which is right here. Then my next point is at 2, 3. And the next one is at 3, 6. And you can see that this point here is symmetric with this point. And this point here is symmetric with this point over here. Okay? Then I'll connect the dots and do my best to make my graph look like a U. I do understand that none of your graphs will be perfect, but as long as you show me you're trying to make it look like a U, you're good. All parabolas should look like U's. And I'll give you guys just a minute to finish that. Okay, we're going to move on to the next section. So if you slide it back up to the top on the right, this section, if you remember, was the axis of symmetry section. You can see in this picture they've already labeled it for you. It's actually a vertical line that is created by the x value of the vertex. Because if you put a mirror on one side of the graph and you look at it, it should match exactly what you see on the other side. That's symmetry. So here when it says the blank, that would be axis of symmetry. Oof, barely made that one fit. Right, too big. The axis of symmetry divides the parabola into two congruent halves. Again, that's shown here in this picture. The equation for the axis of symmetry is x equals -b over 2a. It's that exact same equation that we used to find the x value of the vertex. And then they ask you to find the axis of symmetry given this example. Well, the first thing I'm going to do before I try to solve this equation is determine what is my a, b, and c. Because I need a and b to find the axis of symmetry. So what would the a value be? B? C? Oh man, it's the same one we used before. Makes life easy. Then I'm going to come over here so I have a little bit of room to work. There's not a whole lot of room to work under here. And I'm going to write x equals negative parentheses divided by 2 times parentheses. On the top, I'm going to fill in my b value, which is -2. On the bottom, I'm going to fill in my a value, which is 1. And we've already simplified that, and we found that x equals 1. Now, when you guys write your answers for me on your assignment, I would prefer that you write a of s, which stands for axis of symmetry, colon, then x equals 1. So you're telling me exactly what you're talking about. You're not talking about the vertex value. You're just saying that's my axis of symmetry. And since it's an x equals equation, we know it's a vertical line. Because vertical lines do not touch the y-axis unless they are the y-axis. And therefore will not have y in the equation. X equals a number is a vertical line. It looks just like this. And look, we already did half the work for this one. Yay. So exciting. Okay, the next one says to find the vertex. Well, we already know that to find the vertex, I have to use the x value and then plug it in and find the y value. So we're going to list the steps. Step 1, find the axis of symmetry. Because if you find the axis of symmetry, you have the x value of your vertex. Then step 2, after you find the axis of symmetry, is to substitute x into the equation. And I'm going to abbreviate the word equation to EQ, if you guys are okay with that. Then step 3, solve for y. Then after you solve for y, you'll write it as a vertex in ordered pair form. Oops, I apologize. See, if I don't say step out loud, I totally mess it up. Step 4, you'll write your vertex in an ordered pair form, which is x, y. And you have to have the parentheses and you have to have the comma, otherwise it is not an ordered pair. And then step 5, the actual step 5, you will determine if it is a maximum or a minimum value. And I can't fit the word determine with that because those are long words. Okay? We've actually already found the vertex for this example because we did that over here when we graphed it. So what is the vertex for this equation? The vertex is the ordered pair. It's not just a 1 or not just a 2. It's actually an ordered pair, 1, 2. And then we have to determine if that's a maximum or minimum. Okay? The easiest way to do that is to look at the graph. And if we look back at this graph over here, if this point right here is the vertex, is that the lowest point of the graph or the highest point? That's the lowest. It's a minimum. You can also look at the equation for that. You ready? I'm going to teach you a trick. If you look at the equation and your a value is greater than 0, like a +1, a +2, +3, then you'll have a minimum. If your a value is less than 0, -1, -2, -3, it'll turn your graph upside down like this, and you'll have a maximum. If a is greater than 0, so positive numbers, your graph looks like this, and you have a minimum. If a is less than 0, your graph is upside down like this one because it's a negative, and you have a maximum. It's a good thing we had that extra white space there. Fill in some extra notes. Okay, we're almost done. One more. We can do it. Vertex form of a parabola. This is something we're actually not going to spend a whole lot of time on, but you do need to see the general form. Vertex form is f of x equals a times the quantity x minus h squared plus k, where a cannot equal 0 and the vertex is the ordered pair HK. So vertex form, you quite literally put your vertex as your equation. So you can't mess it up, okay? Now, this one says find the vertex of this equation here. We're going to have to do some work because it's not the same one we've been using. Then after we find the vertex, we're going to write it in vertex form. So what's the first thing I need to do to find the vertex? Find the axis of symmetry. Oh man, all those steps. No wonder I gave you those examples. Oof. Step 1, find the axis of symmetry. Well, I'm going to use the equation x equals negative b over 2a. I know that my a value for this equation is 1, my b value is negative 6, and my c value is 8. I'm going to plug it in. X equals negative 6 over 2 times 1. I've run out of room, so I'm going to draw a little arrow. Negative 6 is a positive 6. 2 times 1 is 2. So I have 6 divided by 2, which is, axis of symmetry is x equals 3. Then I take that and I do what with it? I need to plug it into the equation. Yes, sir. Because that's step 2. I was about to write it, but Mr. Rattler passed me. Slow down a little bit. Did you get caught up? Okay. Step 2, substitute. So y equals 3 squared minus 6 times 3 plus 8. I had to do a little bit of work on this one. It wasn't as easy as the one up here. So I'm going to do show a step. 3 squared is 9. Negative 6 times 3 is what? Oh, I love that. Negative 18 plus 8. Then 9 minus 18 is negative 9. And negative 9 plus 8. Whoo! Did you really just say negative 17? That is negative 1. Somebody's brain farted. That was a really stinky one. Then step 3 would be to write it as an ordered pair. And my ordered pair is 3, negative 1. Ooh, that didn't look like a 3. See? There's my vertex. Actually, this was step 3. Solve for y. This is step 4. Totally messed it up again. Jeez. Apparently, I don't like step 4. My brain cannot process step 4 today. Step 5 is to determine if you have maximum or minimum. Well, I don't have a graph, but what could I look at that would tell me? A, is it a maximum or minimum? It's a minimum. Oop, and I can't abbreviate minimum either, apparently. Just put MIN for minimum. I'm okay with that. Oh, now I can write it in vertex form. Now I can write it in vertex form. I'm going to use this formula here. F of x equals A times the quantity x minus h squared plus k. Now, h is here. K is here. A is literally the A from the original equation. Okay? The only thing that you have to watch out for is you notice this says x minus h. When you plug in h, in this case it's a positive number, so you'll write that as x minus 3. What if this had been a negative 3? You would write x plus 3. You're absolutely correct, Skylar. You would say x plus 3, okay? So when you plug in h, it's like you're changing the sign. You just plug it in with the opposite sign. So in this case, h is positive, so I'll write it as x minus 3, okay? So f of x equals a, and in our case a is 1, times the quantity, x minus 3 squared, plus my k value, which in this case is a negative 1. So do I need to show that plus sign? Nope, I can just write minus 1. Oh man, my eraser didn't work. Minus 1. No double signing. Don't put plus minus. That's awkward. And this is vertex form of that equation. Again, we're not going to spend a whole lot of time on this right now. It's just something I thought you needed to see. Any more questions? Yes, maybe. Okay, after you're done, slit the sides, glue it in your notebook on the next page.